Okay, so here's the next one. In this case, we have two beams. I guess what we're trying to do is measure the weight of this bird using this contraption. And so let's go ahead and figure this out. It says that he's going to use this empty solo cup, and it perfectly balances the system before you put the bird on there. Okay, what does that mean? Okay, basically means that we can look at the added weight of putting pennies in there and deal with just that as well as the weight of the bird. It kind of lets us ignore self-weight of everything, right? It's kind of the effect that piece of information has for us. And let's see. He's added the bird and a number of pennies. It remains in equilibrium. Each penny weighs 0.088 ounces. Okay? Now we have to find the weight of the bird. Okay, what should we draw? A free body diagram. So let's do the upper lever first. Okay? We have the weight of the pennies out here. What's the weight of the pennies? Okay. It'll be 30 times 0.088, which is 2.64 ounces. Okay. What happens at the pivot point? It could have two components of reaction here. Okay. And the letter wasn't given there, so let me just put a letter A right there. Say this is letter A. And so let me call this R-A-Y and this R-A-X. Now what? Okay, so we show a force acting right here. That is the tension in the string. I'll just call it T. All right. Okay, we want some distances. All right, and I think it says here that the, let's see, where does it line up? Remains in equilibrium. Drawing is not to scale. All right. I'll tell you what, I'm going to do this one a little bit differently because it turns out it doesn't necessarily matter very much what exact direction this string goes. I'm going to show you that here. Let me, instead of calling this T, let me actually, well, I'll leave the T on there, but let me show that as two things. I'll call it T sub what?
T sub y.
Maybe T sub y and T sub x. And we'll come back to that in just a second. Okay, what else should I put on this free body diagram? Coordinate axes, and what else? Some distances, right? So A is 70 inches, and this is a large contraption. 70 inches. B is 15 inches. Okay, now what? We have another free body diagram to draw. Okay, the one down here, what happens at this pivot point over on the left side? Okay, two reaction forces there. I have, we'll call that point B. I have RB Y and RB X. And what else? The bird, right? That's the thing we're trying to find. So maybe F bird. Okay, what else? Okay, yeah, I have this other tension in the string. It kind of comes up like this. I called it T earlier, but I also put in a TX and a TY. Okay, the TX and the TY that I had on the earlier free body diagram are the same as TX and TY on this free body diagram because the direction of that T is the same relative to my X and Y coordinate systems.
So why did you
You'll see here in just a second. Question was, why did I add tx and ty? Okay. Quick answer actually is this. Without more information, I can't necessarily find tx. Good news is I don't need to know tx. Okay? So that makes this problem maybe a little bit tricky, is that you don't need to know tx, and so therefore it doesn't matter. I can't find it because I don't know exactly how these two levers are lined up. But it doesn't matter, because only the vertical component creates moments around A and B, and that is ultimately the two things that we're going to do here, is kind of use those two moments. Okay? All right, let's go ahead and figure out then what ty is. Okay, we'll start there. So we sum moments for the upper free body diagram around point A. And I have 2.64 ounces, not Q, ounces. Okay, times what? Times 70 inches. Okay, counterclockwise, so I do count it as positive. RAY and RAX don't create moments around A, so I leave those alone. Then what do I do? TX and TY are just the components of T, so if I deal with TX and TY, I don't have to look at T, right? I put them on there as basically another way of expressing T. But TX does not create a moment around A, so I leave it alone and I can look at just TY. TY creates what direction a moment around A? Clockwise, so I say minus TY times 15 inches. And since that beam is in equilibrium and we are told, you know, that we're not told directly, but the fact that it's self-balanced before we started adding the weight allows us to neglect self-weight of everything in the system. Okay? So from here we can figure out what TY is. Okay? TY is just going to be equal to 2.64 times 70 divided by 15. 12.32 ounces. All right, that's step one. The next one is we need to sum moments around point B for the lower free body diagram. Okay, so this was upper FBD. This is for the lower FBD. All right, so for the lower FBD, we have what? I guess I need to put in some more dimensions here, don't I? This was 74 inches. Okay, and then D is 84 inches. Okay, so I have positive TY times 74 inches. All right, TX does not create a moment around B. F bird creates a clockwise moment. Okay, so minus F bird times what? Okay, 74 inches plus 84 inches. And that's equal to 0. Nice thing is, we can plug in the TY we found here right in there, and we can figure out what F bird is here. Okay. So F bird is going to be equal to, okay, we'll do 12.32 times 74 minus X times 74 minus 8 or plus 84 is equal to 0. We'll solve that for F bird, and that gives me 5.77 ounces. I don't know why I want to draw a Q. Ounces. Okay. Answer is H. All right. Any questions on that one? All right.